Welcome, this is the 2018 through 2019 IM1 Honors Module 1 Review Packet Solutions. This is part 1. It's going to be covering part 1, 2, 3, and 4 in the packet. Alright, so part 1. It asks us, write a formula representing an arithmetic sequence in which the first term is 8 and the second term is 24. Remember, this is an arithmetic sequence. Okay. You can write the recursive or explicit. Right? But for it to be an arithmetic sequence, we have to find the common difference. To find the common difference here, what I did was I did the 24 minus 8, which gets me a 16. If I plug this into the recursive equation, it would be 16 plus the previous term, which is f parentheses n minus 1. Next, I can put it into the explicit form, which looks like y equals mx plus b. So it would be an is equal to 16n, right? 16 is the difference, n, right, plus b. The b represents the y-intercept. In our case, it would be negative 8. How did I get negative 8? How do I get the 0th term in the y-intercept? I apply the common difference, but I apply that backwards. So 8 was the first term. Subtract that from 6. Subtract 16 from 8 gets me a negative 8. That is how I get the y-intercept, or the 0th term. Next, the second thing asks us for the same thing, but it says here that our third term is 24 and our first term is 8. Okay, you could do this in many different ways, but I'm going to apply the slope formula in my case. y2 minus y1, so it's going to be 24 minus 8 divided by y2 minus y1, which is going to be the third term minus the first term. Right? Simplify that, gets me 16 over 2, which simplifies into 16 over 2 should be 16 over 2 should be simplified to 8. Okay, that is why I plug in 8 here for the common difference. The explicit again, an is equal to 8n plus 0. How do I get the 0? Which is the 0th term. I apply the common difference backwards. So this was 8, which is the first term, so I subtract the common difference. So 8 minus 8 will get me 0. The next one, this one, the first term is 8, the fourth term is 25. The common difference here is, it's not 8. The common difference is not 8. I know I did the calculation here. It's 17 over 3. Right? Again, apply the slope formula. Plug that into the recursive equation, so it would be 17 over 3 plus the previous term. If I put that into the explicit, 17 over 3n plus y over 3. How do I get the 7 over 3 for the y-intercept? Again, I apply the common difference backwards to the first term. The first term was 8. Subtract 17 over 3, which is applying the common difference backwards. That gets me 7 over 3. Part 2, it asks us to determine if the following is an arithmetic, geometric sequence, or neither. The first one, okay, we have a table. I'm going to test for the common difference, which will get me an arithmetic. So I test the common difference. 4 minus 8 or 2 minus 4, two different values. There's no common difference there. Common ratio, 4 over 8 or 2 over 4 gets me 1/2. So I would say this is geometric because there is a common ratio. B. I again first start testing the common difference. So 4 minus 8 gets me negative 4. 0 minus 4 gets me negative 4. I see there is a common difference, so I would call the sequence an arithmetic. So I stop here because I know there is an arithmetic. It's an arithmetic sequence, so I do not have to test any further. C. I have the sequence 1, 1, 2, 3, 5, and 8. I test for the common difference. I saw there was no common difference. I even tried multiple terms. I saw no common difference. I test for the common ratio. I saw that it kept changing, so there's no common ratio. Because there is no common difference or common ratio, I say it's neither arithmetic or geometric. If you would like to know the side note, this is a special sequence called the Fibonacci sequence. The next term is a sum of the two previous terms. That is the pattern for the Fibonacci sequence. D, 1/2, 1/4, 1/8, and 1/16. You see it's already growing almost rapidly, so we're almost guessing it's geometric. But let's test for the common difference. We saw that there is no common difference. Let's test for the common ratio, okay? 1/4 divided by 1/2, 1/8 divided by 1/14, 1 over 4. If you find it difficult to work with fractions, you could always put into a decimal, then divide, okay? And you should get a 1/2 here for the common ratio. Therefore, we say it's geometric. Alright, there you go. Let's look at point 3 now. Part 3, it says to write the explicit function in function notation that represents the expected bacteria of the doorknob, where T is the number of minutes that have passed since the current minute. So it starts here at 50,200 and is expected to grow at a rate of 8% per minute. The fact that it says an 8% per minute, it means it's geometric because it is a percentage. So if I plug this into our geometric sequence, I get this. Okay. The R is going to be 1.08 because it is a growth rate, right? R has to be greater than 1 for it to grow, and it says it is a growth rate. Alright, so the explicit equation could look like two ways. It could look like this way, which is the previous term times r to the power of t minus 1, or you could see it using the zero term, which is 0 term times r to the power t. Okay, you can see it this way or this way. In our case, the fact that we have the 0th term, we're going to use this. Okay? Alright, so that is the 0th term, 50,200, times your r value, which is 1.05, to the power of t. Right? It's not t minus 1. It's only t minus 1 when you're only using the first term. But in our case, we're using this one, which is the function is equal to the 0th term times r to the power t. Next, the current zombie population of a small town is 20,000, and its population is expected to decay at a rate of 20% per month. Again, it is a percentage, so we see that it's geometric. Again, this is the two explicit geometric sequence. The one using the first term and the other one using the 0th term. Notice that we have the 0th term here, which is 20,000. Therefore, we're going to use this one, which is function of n is equal to the 0th term, the function of the 0th term times r to the power t. We see that it is a decay rate. Please look, notice that it is a decay rate of 20%. Therefore, which 1 minus the 0.20, which is your 20%, gets me 0.80. That is our decay rate. R is equal to 0.80. Because it is a decay, it is 1 minus that. It is always less than 1. Good? So your solution is f of n is equal to 20,000 times 0.80 to the power t. Good? Alright, let's look at 4 now. 4. We have this sequence here, right, of shaded blocks. Which of the following function gives the number of shaded blocks for the figure n? Really weird. There's multiple choices, so the best way I could do this is to put it in a table, in a chart, to make things much easier. Figure 1 had 8 shades, figure 2 had 12 shades, figure 3 had 16 shades, and 4 had 20 shades. Okay, because I'm trying to generate these equations. Okay, I could do it many ways. I could try to write the recursive or explicit and work from there. Okay, but in our case, the fact that I have these solutions, I'm just going to work backwards. I'm going to test out each formula one by one, which is going to be the simplest way. So I test the first one. I plug in 1 here. If I plug in 1 for the n value, I have to get an 8 out. I test the first one. It does not equal to 8, so that doesn't work. Next one, I substitute 1 in here. I should have gotten 8 again for the shaded box, but I did not. So that one doesn't work too. Next one, I plug in 1 here into the function, and I do get 8. It is correct, but I should always check the second term to see if the pattern consists. Here I plug in 2 for the n value, and I saw that it is equal to 10. If I plug in 2, I should get a value of 12 as the output. I do not get 12. Okay, so it doesn't work. Okay, next, again, I will test out 1 should be equal to 8. I plug in 1 here. Simplify, it gets me 8. It's good. I should always check the second term. Right? I plug in 2 for the n value and I get 12. Right? Looks 2 gets me 12. Perfect. So it is correct because it equals to 12, so that is the correct function. So there you go. That is your solution for the part 1, which covers part 1, 2, and 3, and 4.